Hello students, welcome to the lab on sea level rise. So here we are, we will be performing a small experimentation that I will be doing in front of you. But before we do that, the reason why we are doing this little experiment, it's quite strong evident that sea level water is rising, and unfortunately they will keep rising until we stop global warming. So there's a global intergovernmental panel on climate change data that I will be sharing with you in the lab has strongly given evidence that the sea level will rise from 1.5 millimeter to 3.5 millimeter by the end of the century, which is by 2200. It will keep rising to the level of 3.5 millimeter until global warming is stopped. So that's the little data that I gave you, but we will expand more of that in the class. So in this experimentation today, there will be two phenomena that you will be learning. One will be the thermal expansion, and this experiment involves that. And however, the second one that I want to touch base is the melting of the glaciers, and that's something I will be doing with you and asking you to do that at home, and I will explain that more in the class. So however, I'm going to continue with this thermal expansion phenomena. So I have prepared the flask. By the way, this is just the water. And we have added the colors so that you guys can see the actual experimentation, and the intention for you to see is the rise as we heat the water molecules. So that's why we end up adding the red color in it, so it captures well. So eventually what I'm going to do is I'm going to use this heating mantle. I have set it to the 100 degrees Celsius, and I'm going to put this flask on it, and the recording that I'm going to do out of this setup is the temperature reading that I'm going to take and corresponding rise in the water level. So that's the little experimentation for us to do together, so that at the end of the day, that the data worksheet that I have given you as part of your lab, so that you guys are able to answer some questions that are part of your worksheet. So I will be collecting around 5 to 7 set of readings doing this experimentation in front of you, and we will go from there. So my intention is to record the water level as the temperature increase every 2 degrees Celsius. So every 2 degrees Celsius increase, I will take the rise in the water level from my ruler that I have attached in the setup. Okay, so let's take our initial reading before we start heating our sample here, the water sample. So our very first reading will be in my thermometer showing me 28 degrees Celsius, and that's what will go in my data sheet, 28 degrees Celsius for temperature. And on my ruler, the level for water will be recorded as 5 centimeters. So that's our starting point. So once you have that data recorded in your data sheet, I'm just going to put this into my heating mantle, and we will let it warm up a little bit. And as I said before, it's at 100 degrees Celsius. So now all we have to do is wait for it to warm up, okay? And my intention is to take a reading, hopefully by the change in temperature of 2 degrees Celsius every time. Okay, so my water level is rising, so I'm going to start taking readings. So I will take my next reading. Let's say my next reading will be at 30 degrees Celsius, and my starting point was 5 centimeters, and I have reached at 7 centimeter already. And I will continue looking at my setup just so that I don't miss any reading. So that's at 7 centimeters, and if you notice, it's continuing going up as it's warming up. So this is the experimentation to show you the thermal expansion. In other words, how the molecules of water expand as they get heated, and that's what contributing to in bigger picture the sea level rise. might take a little while now, just because it's warming up slowly and it's a lot of volume for it to get warmed. But I'll keep showing you. See, last reading we had at 7 and we are 8 already. And I'm going to show you the temperature as well, right there. So the initial warming will take a little while because the water was still at like a tap water temperature. But eventually you will see once we have first few readings, 2 readings, it'll be faster. So you see I'm already going up and I've reached at approximately 9 centimeters. Yeah, and so is temperatures going up a little bit as well. I'm going to keep looking. Okay, I think I'm going to go ahead and take my reading. And I'm at approximately 10 centimeters. So you notice like how with a certain degree change in temperature, we get a big installment of change in centimeters in water. So I have 2 readings so far. I think I'm going to take 5, total 5, so 3 more. So it has gone up 1 centimeter already. Last was at, sorry, approximately 1 centimeter, yes. So last one was at 10 and now I'm at 11 already. So I'm at 12 centimeters approximately now, and I will take that as my 3rd reading, and so will be my temperature. And it looks like temperature is moving really slow here. So there's an exponential change in terms of the water level rise. It's not corresponding to the same value as temperature, because even the slight change in temperature is bringing more expansion in the water. So if let's say like 1 degree Celsius, I have seen from 0, like the starting point was at 5, so it changed approximately 2 to 5 centimeter within 1 degree Celsius change. So that's the exponential I meant to explain. Okay, so we surpassed 13 and 14. I'm at 14 now, approximately. So I'll give it some more time. So we have a good data set for us. And if you look at the temperature right here, it is going up as well. So we started at 28 and now we are close to approximately, last time I recorded 33 and now I think I'm hitting 34 or 35. Okay, and I think I'm going to take this as my reading as well, because its temperature has changed from last time. So I hit, if I look closely, I would take this as 15 centimeters. So within the change to 2 degrees Celsius, starting point was 5, we have gone up 10 centimeters. So that's what the exponential means here. So 2 more data sets and then we should be good. And I really want to bring your attention to this. It took a while for the water to expand, but now it's all warm up and it's expanding really faster. I'm going to keep looking at my thermometer as well, and then here, and I think this is where I will, or maybe let me see my temperature. Yeah, I'll give it a little more time. Okay, I think I'm ready to take the reading here, and it's another 3 centimeter change from my previous, which was 15 centimeters, and I took the reading at 18, and there's a change in temperature as well. It has gone up approximately 1 degree Celsius. Yeah. Okay, so I have 5 readings so far. Let's take another reading just to get a good data set, and then we'll just call it a day for this, because I want to see some change in the temperature happening as well. Remember, we started at 28 and now we are way above 30, 35 degrees Celsius. Okay, let's give it another centimeter to move up, and that way my thermometer will move up a little bit as well. Yeah, even though the instruction says we will be taking readings every 2 centimeters, 2 degrees Celsius change in temperature, but I just made a little change because it was expanding really fast, so I took the reading at every degree Celsius. Okay, and I think I'm going to take my reading now. So we will call this our final reading, and I'll take the temperature reading as well, and we should get a good data set right here. Okay, looks good to me. So 1 degree Celsius apart. So that's what I meant to show through this little experimentation, is the effect of heat on the water and how it caused the water level to rise as it gets heated up slowly and steadily. So thank you very much.